Myth number 1, titanium's perceived weight savings. When users talk about incredibly light titanium chairs, what does that mean? For example, frames. How much weight does a titanium frame really save? To understand, let's begin by looking at the difference between a block of titanium alloy commonly used in wheelchair manufacturing and an identical block of commonly used aluminum alloy. Place them on a scale and the titanium sinks like a rock. Why? Because titanium alloy is 63% heavier than aluminum alloy. So why does everyone say titanium is the ultimate in a lightweight material? The answer, material strength. Titanium's strength is almost double that of aluminum. So how do we compare these measures of strength and weight? If we just look at the strength to weight ratio, titanium would appear to be slightly better. However, if we dig deeper, there is a third variable, material shape. Strength is a component of shape and form. Consider the following. A thin strip of wood like this is easy to break when held flat. However, if we take an identical piece and hold it vertically, it becomes almost impossible to break. That is because when held vertically, the structural strength is much greater. So we have material weight, material strength, and material shape to consider. Not to mention the thousands of different ways a frame can be loaded and stressed. How do engineers weigh all these variables at once? Finite element analysis, or FEA. FEA analysis is essentially a way for engineers to tell when something is nearing its breaking point or theoretical fatigue limit. It is a computer program that calculates the theoretical fatigue limit of an object under a specific force in a specific location. So let's use this tool to see if shape can change the strength to weight advantage of titanium frame tubing. On the left, we have a section of round titanium tubing. On the right, we have a section of oval 7000 series aluminum tubing. Both sections have identical weight. If we apply a 100-pound force to the base of each tube, the titanium tube will reach 48.5% of its fatigue limit. The aluminum tube will only reach 41.5% of its fatigue limit. As you can see, the aluminum tubing in its oval shape can handle more stress. Also, if we make the fatigue limit ratio the same for both tubes, the round titanium tube will actually weigh 11% more than the aluminum tube. This shows that aluminum tubing in an oval configuration can be engineered to weigh less and therefore will be stronger than titanium frame tubing. But how important is the tubing to the weight of the chair? Using the Quickie GTI frame as an example of a typical rigid ultra-lightweight chair, the frame is 15% of the overall weight, while the rest of the components are 85% of the overall weight. When manufacturers claim a new chair weighs significantly less than an older model, they are usually taking out the weight in everything but the frame. Small reductions in things like fasteners, redesigned brackets and forks, lighter wheels, less bulky upholstery, etc. make up the primary difference in weight. All of which points to two conclusions. 1. The weight of a frame is a complex combination of material weight, material strength, and material shape. A simple strength to weight ratio does not tell the whole story. 2. Wheelchair weight is more a function of overall chair design than simply the frame materials. To look at it any other way is simply a myth.